Chemical reactions and equations. An atom of an element is represented by a symbol. The molecule of a compound is represented by a formula. A chemical change is represented by an equation. Symbolic representation of an actual chemical change is a chemical equation. To write an equation. Substances which take part in chemical reaction, that is reactants, are usually written on the left-hand side, and substances formed as a result of chemical reaction, that is products, are written on the right-hand side. The reactants and products are separated by an arrowhead mark which starts from reactant and points towards products. Each reactant or product is separated from one another by plus sign in between them. The numbers of atoms of the substances on both sides are equalized. This is known as a balanced equation. It is a skeleton equation. We can convert it into a balanced equation. Like this. The reactants appear on the left and the products appear on the right. The arrow joining them indicates the direction of the reaction. An integer precedes the formula of each substance. These numbers are known as stoichiometric coefficients. The stoichiometric coefficients in a chemical equation are the set of smallest integers that give a balanced equation. In a chemical reaction, total mass and charge of the reactants is always equal to the total mass and charge of products. Chemical reactions can be divided into various classes. This classification is based on the specific characteristics and the nature of the reactions. It is divided into 6 major types: synthesis reaction, decomposition reaction, single displacement reaction, double displacement reaction, combustion reaction, and redox reaction. In a synthesis reaction, 2 or more elements or substances combine together to form a new substance. For example, when a mixture of hydrogen and chlorine is placed in sunlight, hydrogen chloride gas is formed. In a decomposition reaction, a substance is decomposed into 2 or more simple substances. For example, when calcium carbonate is heated, CaO and CO2 are formed. In a single displacement reaction, a more reactive metal replaces a less reactive metal. For example, Fe replaces Cu in CuSO4 to form FeSO4. In double decomposition reactions, mutual exchange of radicals takes place. For example, silver nitrate reacts with potassium chloride to form potassium nitrate and silver chloride. In a combustion reaction, substance rapidly combines to form 1 or more oxides and releases energy. For example, CH4 reacts with oxygen to give CO2 and H2O. Oxidation-reduction reaction. This is known as redox reaction. For example, when zinc metal is exposed to oxygen at high temperature, it reacts to form zinc oxide. Electrons are transferred from zinc to oxygen, creating oxides and zinc ions. This is an example of oxidation and reduction reaction. Here zinc undergoes oxidation, whereas reduction of oxygen takes place. Oxidation. According to the electronic concepts, oxidation is a process which involves loss of electrons by an atom or group of atoms. For example, zinc ion is formed from zinc atom. Reduction. According to the electronic concepts, reduction is a process which involves gain of electrons by an atom or group of atoms. For example, sulfide ion is formed from sulfur atom. Combine it to get the formation of zinc sulfide. Here zinc reduces sulfur atom, hence zinc is called a reducing agent, and sulfur oxidizes zinc atom, hence sulfur is called an oxidizing agent.
Oxidation process involves addition of oxygen or addition of electronegative radical or removal of hydrogen or removal of electropositive radical. And reduction process involves addition of hydrogen or addition of electropositive radical or removal of oxygen, or removal of electronegative radical.
Oxidation number. The phenomena of oxidation-reduction processes in covalent and ionic substances is explained by oxidation number. Oxidation number is defined as the charge which an atom appears to have when all other atoms are removed from it as ions. It can have positive, zero or negative values depending upon the state of combination. For example, in NaCl, oxidation number of Na is +1 and oxidation number of sulfur in H2SO4 is +6. Balancing redox reaction. The number of atoms of each kind on one side of the equation must be equal to the number of atoms of the corresponding elements on the other side. Means, the law of conservation of mass should not be violated. There are two ways of balancing a redox reaction. They are oxidation number method and ion electron method. Oxidation number method. Step 1. The oxidation number of each compound is determined and then the change in oxidation number of the compound is also determined. Step 2. The increase or decrease in oxidation numbers per atom is calculated and equated by multiplying the formulae of the oxidizing and reducing agents. Step 3. All other atoms are then balanced. Ion electron method. Ion electron method is done by using half reactions. Step 1. The change in oxidation number of the compound is determined. Step 2. The complete equation is then separated into two half reactions, one for the change undergone by the oxidizing agent and the other for the change undergone by the reducing agents. Step 3. The individual half reactions are balanced by the oxidation number method and multiplied by suitable numbers so that on adding the two equations the electrons are balanced.